Jai Hind everyone. So today we are going to talk about the subject Basic Data Structures and Algorithm. This is an open elective subject for second year students. Today we are going to focus on the topic sorting. This term sorting is very much familiar to us. We have used this term many a times. We are using this term many a times at number of places. If I'm talking about the sorting in terms of computer system, we can say that we are arranging something in a particular order. So in normal way, sorting refers to ordering data in an increasing or decreasing manner according to some linear relationship among the data items. So if we have certain number of elements, and we want to arrange them in a proper sequence. That sequence is maybe in the descending order or maybe in the ascending order. Then what we need to do? We need to perform certain steps. We need to perform or opt certain techniques to arrange them in a proper descending or ascending order. So we have a number of different techniques. They have different solutions, different methods. According to the requirement, they have their different advantages as well as disadvantages. But today, the topic on which I am going to focus is the quick sort. Basically, this quick sort uses the divide and conquer technique. Divide and conquer means whatever problem we have, whatever number of elements we need to sort, we will divide them one by one. And finally, after division, at the end, we will start combining them, which is known as conquer. So divide and conquer technique is used in this quick sort. So I'm going to explain you this quick sort with the help of an example. After that, we will talk about what are the pseudocode or algorithm for this particular technique, and what are the advantages and disadvantages of using this sorting method. So let's take this example. We have certain elements with us. They are shuffled and we need to arrange them in ascending order with the help of this quick sort. As we know, it uses the divide and conquer method. Means whatever big problem we have, we need to divide them in small pieces, in small modules, and finally we need to combine them. 35, 50, 15, 25, 80, 20, 90, 45. We will start with this particular number. We will take it as pivot. There are different methods to use this. There are different methods to solve this technique. Maybe we will take a particular element as pivot, which is on the leftmost side or on the rightmost side or somewhere in between. We are going to discuss it with the help of the element, which is the very first element of this unsorted. This one. This is 35. This is pivot. Always take the next element to this pivot as a start element. And here, the last one is the end element. Whenever we start this comparison, we will put an infinity sign on the rightmost side. What is the purpose for it? Let me explain it. What we will do, we will start comparing this pivot one by one with this start element. And if the start element is smaller than the pivot, we will move forward. Then again, we will check the element and compare it with the pivot element. If pivot is larger, then again we will move forward till the time we will get an element which is greater than pivot. So here, start is here. What we are doing? We are comparing this pivot and this start. Which one is greater? Is pivot less than start? Yes. If it is so, then we will stop over here. Now, let's start with the end button. Over here, end. 45. We need to check whether this element at this end position is smaller than pivot or not. 45. Is it smaller than 35? Now I am comparing this pivot and this end condition. This end should be smaller. This is larger, so we will move forward. Now end will be here and is removed from here. 90 and 35. Is 35 greater than 90? False. If it is false, we will move forward and we will update the value of end. Now, this 35 is greater than 20. True. This is true. We will stop here. Now, after doing all these things, we need to check the position of start and end. If start and end crossed each other, then we will swap P and E. Otherwise, we will swap S and P. Sorry, S and E. So these are the two conditions. If crossed, then swap P and E. If it is not crossed, then swap S and E. So let's look into this. Here we have start, here we have end. They have not crossed each other. So in that case, if it is not crossed each other, then we need to swap S and E. So let's swap less. It is 20. Then it is 15, 25, 18, 15, 19, and 45. Alright. 35, 20, 15, 25, 80, 50, 90, and 45. This is your start. And this is your end. This is your pivot. It is like this. Now again we will start comparing it. We will compare these two according to this particular condition. P less than S. True. We will move forward. 15 less than 35. We will again move forward. 25 less than 35. We will again move forward. So we have S over here. As we have moved it like this in the end, here we have moved the start. Now, start is here because 80 is greater than 35. We found that element which is greater than pivot. So what we will do now, we will start comparing with this position. This E. E is, we need to check whether this pivot is greater than E. Pivot is greater than E? No. We will move forward. Pivot is greater than E? No. We will move forward. Pivot is greater than E? Yes. So new E is here and it's somewhat like this. So here's the situation whether this E and S crossed each other or not. Yes, they have crossed each other. So in that case, when they have crossed each other, we need to swap P and E. So we will swap P and E. This is 23, 25, 20, 15, 35, 18, 15, 19, and 45. So now you can see that this 35 is here, pivot is here now, and it has divided this complete problem into two halves. And in these two halves, all the elements which are on the one side of 35, they are less than 35, and on the other side, all the elements which are greater than 35. Now, you can see that we have put infinity everywhere. Why we have used this infinity on right hand side? Because when we will keep on comparing this value of S, and at a point of time, some of the situation will be somewhat like this. Just for example, that all the elements on the right side of this pivot are smaller. Then when we are comparing this situation, P is less than S, we will keep on moving like this towards this direction, and we will not get that particular situation or condition at which we will stop. So to get that stop situation, what we will do, we will put an infinity. Definitely, whenever we keep on comparing this pivot, you know that pivot, if it is smaller, then infinity, yes, then definitely it will stop. If all the elements are smaller, even then, reaching at the end, when we find that infinite, then definitely it will stop. The problem will stop automatically. Just for that purpose, we have put it over here. So right now, this is the situation. This is pass 1. Whatever we did from here to here, it is your pass 1. This is pass 1. Now we will start second pass. You can see we have divided this problem into two halves. Now this is one array for us and this is another array for us. We will work on it, divide it into two halves. Then we will work on it, divide it into two halves. Like this, it will keep on going forward. This problem will move forward like this. As one by one, we will keep on going forward. So I am copying this particular stage, this particular step on our next page. So this is next page. 25, 20, 50. 25, 20, 15. 35, 80, 50. 35, 80, 50. 90, 45. Here it is. So now I'm going to take this first half. This is the pivot in this first half. We are going to solve this problem like this. This is the pivot. This is the start. This is the end. And infinity is here. Now, start comparing these two. It is smaller? Yes. We will move forward. It is smaller? Yes. We will move forward. It is smaller? No. It will stop here. Alright? Now, it will move forward. It is smaller? Yes. It will be here only. S has reached over here at this point of space and E is over here. They have crossed each other. So when they have crossed each other, we will swap P and E. So this is E, this is P. What we will do? 15, 20, 25. This is the situation now. So we have sorted this particular array. Come here, this is P and this is your start, this is your end. Now start comparing these two. This is smaller, we will move forward. This is greater, it will stop here. It is already smaller, it will stop here. So in this case, they have not crossed each other. When this S start and end will not cross each other, we will swap these two with each other, S and E. So now the situation is somewhat like this. Pivot is there. It is 50, 45 and 90. So this is your S, this is your E. Alright? S and E. This end start and end is there, S and E. What we will do now, we will compare. Again, we will start. We will move it forward. S will come here. We will stop over here. This is greater. We will move forward. We will stop over here. Because we are checking the smaller elements. So end is over here. So if these two have crossed each other, then we need to swap P and E. So now 45, 50, 80 and 90. Now you can see this one, and this one. This is a complete sorted array. 15, 20, 25, 35, 45, 50, 80 and 90. So this is a sorted array using quicksort. Let's have a look on one more example to make this particular point more clear. This is the pivot P. This is your start. This is your end. Start and end. Now, compare these two. It will move forward. It will stop here. Compare these two. This is already smaller. We will stop here only. So swap S and E because they have not crossed each other. This is the question. This is your S, this is your E. Now again start comparing. It is a smaller, it is a smaller, it is a smaller, it is larger. It will come here. It is a smaller, it is greater, it is a smaller. We will stop here. Swap these two. Pivot will remain here. And it is like this. This is your start. This is your end. Start and end. Now again we will start comparing. It is smaller, it is smaller, it is larger, we will stop here. Then it is smaller, we will stop here. This is S, this is E. Then we will swap E and 54. 31, 26, 20, 17, 44, then 54, 77, 55 and 93. So you can see this pivot 54 is here and it has divided this complete array into two halves, which is left half is consists of all the smaller elements in comparison to pivot 54 and the right side is having all the greater elements in comparison to this pivot 54. Now in this case, again the problem is divided into two halves. In this part, we will take 35 as pivot, and here we will take 77 as pivot. So when we will do this, this is your start, this is your end. It is smaller, we will move forward. It is smaller, we will move forward. It is smaller, we will move forward. S is coming here. This is greater and this is smaller. E will come here. So they have crossed each other, so we will swap this pivot with E. So now it is 17, 26, 20, 31, 44. So you can see here are one element, here we have three elements. So again our problem has divided into two halves. We will take the left half now. This is your pivot. Now this is your pivot. S, E. Start. It is greater, we will stop here. This is smaller, greater, we will move forward. It is greater, we will move forward. It is smaller. So it means pivot will be swapped with E, it will remain here. Now, this part is the problem. This is pivot, this is start and end both. Start is this, end is this, so they will be swapped with each other. So here it is going to be like this. 17, 20, 26, 31 and 41. 54 is here. Now in this case, we will take 77 as pivot. This is your start. This is your end. This is start will move forward and it will come here and it will come here. And they have changed their positions. So now swapping will take place. This 55 will come here, 77 will come here, 93 will come here. So now you can see this, and this. This is your complete sorted array. 17, 20, 26, 31, 44, 54, 55, 77 and 93. This is your sorted array. So this is the way how we have solved this quick sort method with divide and conquer technique to solve or to sort a particular given unsorted array, where we have taken the pivot as the leftmost element. So let's have a look on its pseudocode. Basically, in this we are having an array. This is a pivot and this is rear. Pivot, basically you can say the first element here we can say as P and last element as R. So we will check this condition. Now we will partition it like this. From A, P, Q we have first array and second array is from Q plus 1 till R. After this we will check all these conditions. Whenever it is going to be true, we will swap it, otherwise we will not swap it, as we have already performed it in our previous steps. So this is the advantages and disadvantages of quicksort. If we will talk about advantages, the plus points is it is a divide and conquer algorithm that makes it easier to solve the problems. Second, it is efficient or large data sets. It has a low overhead as it only requires a small amount of memory to function. Disadvantages of quicksort: it has a worst case time complexity as big O n square, which occurs when the pivot is chosen poorly. It is not a good choice for small data sets. It is not a stable sort, meaning that if two elements have the same key, their relative order will not be preserved in the sorted output in case of quicksort, because here we are swapping elements according to the pivot's position without considering their original positions. So that's all about our first kind of method, that is quicksort. We will talk about the next any other kind of algorithm regarding sorting in our next lecture.